Hi, again welcome to Jana Learning. Today's topic is bipolar junction transistor structure. So, bipolar junction transistor, that is BJT. So, it is a 3-layer 2-junction 3-terminal bipolar semiconductor device, and basically it is a silicon or germanium crystal containing 3 separate regions. Now, the 3 terminals or regions are named as emitter, base and collector. Now the term bipolar, it means both the electrons and holes or majority carriers and minority carriers take part in conduction here. And there are 2 types, that is PNP and NPN. So here is the structure of NPN transistor and PNP transistor. So in NPN transistor, that is a P region is sandwiched between 2 N regions. That is, here emitter is an N region, base is P region and collector is N region. And in case of PNP transistor, an N region is sandwiched between 2 P regions. Emitter is a P region, base is N region and collector is P region. Now regarding these regions, actually the emitter will be heavily doped, and the main function of emitter, it is to emit or inject electrons in the case of NPN transistor and holes in case of PNP transistor. Okay, why? Because we know that in N region the majority carriers will be electrons, okay, and in P region it will be holes. So in this case, in NPN transistor, an emitter is an N region, so in this case emitter emits electrons to the P region, okay, and in this case in PNP transistor, emitter emits holes to the N region. And the base region is lightly doped and it is thin, and its function is to passes the electrons or holes to the collector, that is electrons in case of NPN transistor and holes in case of PNP transistor. And the third region, that is collector. In collector, the doping level is in between the emitter and base, and physically it is larger than emitter. And the function of collector is to collect or gather electrons or holes from the base. That is, in case of NPN transistor, electrons are collected in the collector, and in case of PNP transistor, holes are collected from the base to the by the collector, okay. And it is physically large than the emitter. Why? Because it is required to dissipate more energy in collector. That's why it is physically larger than the emitter. Now the 2 junctions, that is the 2 junctions in the PNP transistor and NPN transistor. The 2 junctions are emitter base junction and collector base junction. The emitter base junction is also known as emitter junction, simply emitter junction, and the collector base junction is known as the collector junction. So in the NPN transistor, the emitter base junction is this one, that is the NP, and collector base junction is this PN. And in case of PNP transistor, this is the emitter base junction, this PN, and this is the collector base junction. So we can say that transistor is like two PN junction diode connected back to back, okay. Now the symbol of NPN transistor and PNP transistor. So this is the symbol for NPN transistor. This is the emitter, collector and base. And this arrowhead, actually the arrowhead points in the direction of conventional emitter current from P to N. So in this case, the current flow will be from P to N. Emitter current flows from P to N as electrons are passing from N to P. So the current will be from P region to N region, that is in outward direction. That's why the arrowhead is pointed in this direction. And in case of PNP transistor, here this is the direction of the emitter current, that is from P to N, as holes are emitted to the base region. So holes move in this direction, so the current flow in the same direction. That's why the arrowhead points in this direction, that is the inward direction, okay. So that's about the basic structure of NPN transistor and PNP transistor. And actually the NPN transistor is found to be more suitable as major part of the current is transported by the electrons. Okay, so that's it. So thanks for watching the video. For watching more videos, please subscribe our channel Jnana Learning.